Alright, so today we're going to be taking the derivative of the vector. And the vector in this case is this is the x component of the vector, which is t squared, and then this is the y component, which is t squared plus 6t plus 5. And we're going to actually be taking the second derivative of this, which would be d2y dx 2. And then these are the formulas for the derivatives for vectors. So the first derivative, dy over dx, equals dy over dt all over dx over dt. And then the second derivative would be the derivative of dy over dx, or the first derivative, over dx dt. Alright, so for the first derivative, it's pretty simple. dy over dt over dx over dt. So for dy over dt, it's just easy. It's just derivative of the y component of the vector, which is, in this case, just 2t plus 6. And then for the derivative of the x component of the vector, which is just t squared, it's just 2t. And that's our first derivative. And if you're trying to find like slope or something out of that, you just use the first derivative and plug in t value for that to find slope or something. But for the second derivative, then you need to use the derivative of this all over the derivative of dx dt. So for the derivative of all of this, we need to use a quotient rule. So we actually take the derivative of the top, which is 2, and the derivative, just the bottom times the bottom, which is 2t, and then derivative of the bottom, which is 2, times the top, which is 2t plus 6, and then all over the bottom squared, which is 2t squared. And then, so it's all that derivative over dx dt, which in this case is just 2t, the derivative of t squared. So for that, then we just need to simplify. So we can simplify to this at first, and then down to here. And then finally, this would be our answer of the second derivative of a vector in terms of t. So, yep, that would be our final answer right here.